Okay, so today we're going to carry on with 8.4, which was our applications of the normal distribution. Okay, so we talked a bit about this last time, and we said that we could do this thing called a Z transformation. So a Z transformation essentially used this formula where we took every element x that was in a normal distribution that did not have this mean of 0 and standard deviation of 1. So it was not necessarily that standard normal distribution. And we took every term x and we subtracted the mean from it. And what that did was it essentially gave us this normal distribution whereby it centered our mean back at 0. But our standard deviation at that point is still sigma. So when we draw it out, we end up with a diagram that looks like this. So we've still got a standard deviation of sigma, but a mean of 0. So that's what this top part of our equation gives us. But now what we want to do is we want to divide by the standard deviation. So if I do that to every single term along here, we'll see that 0 divided by sigma, well, that's still 0. And when I divide each of these by sigma, what you essentially end up with is your standard normal distribution, which the curve may be squished or widened out depending on what sigma was, but you at that point get back to a normal distribution where you have a mean of 0 and a standard deviation of 1. So that's what this Z transformation does. It takes any normal distribution where you have this mean of mu, okay, so the mean could be anything you like, it does not have to be 0. And again, a standard deviation, we'll call it sigma, where sigma can be anything, it doesn't necessarily have to be 1, and it brings it back to that standard normal distribution, that Z distribution that has that mean of 0 and standard deviation of 1. Okay, so what we want to do now is to do some of those calculations that we did in the last class where we were looking at how can we find the probabilities of landing between 2 points, which was essentially the area under the curve between any 2 points. So let's say we were looking at the probability of landing between -1 and 1, well, that was essentially the area under the curve between those 2 points. So we looked at that, and that used that normal CDF function where we typed in normal CDF, we typed in our lower bound, which in this case would be -1, and our upper bound, 1, and then the mean and the standard deviation, which when you are in standard normal, your mean is 0 and your standard deviation is 1. So you did normal CDF, -1, 1, 0, 1, and that would give you your probability. In this case, it's about 0.68, as that's the area under the curve due to our empirical rule. But now what we can do is we can extend that. So we can look at these probabilities where we don't necessarily have a mean of 0 or a standard deviation of 1.